Hi everyone. In the previous videos, we have discussed about elements of electrical circuits. Here, we are discussing about classification of electrical elements. On what basis, on what parameters, we are going to classify the electrical elements. First, we will take the active and passive components or active and passive elements. So these are the components are differentiated based on the different parameters. Okay, like nature of the source, its functions, gain, power gain, controlling the flow of current, nature of the energy, requirement of external resistance, external sources, etc. Depending upon the different parameters, these elements are classified into active and passive elements or components. Active components are elements or devices in which these are capable of providing or delivering energy to the circuit. These are called active components or elements. So that means these are elements which produce the energy to the particles, or you can say to the circuit. Okay. Passive elements are components or the devices which do not require any external source for the operation and are capable of storing in the form of voltage or current in the circuit. Particularly here, already we have seen active elements, those are the sources, right? Providing the or delivering the energy to the circuit. That means if we are taking any electrical circuit, either battery, okay, or generator, we can use for the supply providers. Generally those are the active elements, or here we can take like a voltage source, current source. Those are also we can take as a energy sources in electrical field, right? Similarly, in the case of passive elements, so those are not required any external sources. It won't require any for the operation. Those are generally passive elements. In electrical, we have three types of passive elements. Those are, that is RLC, resistor, inductor, and capacitor. Right? So the resistor, it won't store any energy. It allows and stop the only flow of current. Okay. So remaining two elements, capacitor and inductor, these two are storing energy. Capacitor stores the energy in electric field. Inductor stores the energy in the magnetic field. Okay, so these are the passive elements. Now, in all the applications, these elements are using either active elements or passive elements. In any one circuit, if you are taking any electrical circuit, if it is complete electrical circuit means minimum one source, it may be voltage source or current source, minimum one source it should be, and remaining elements, it may be either R or RC or RL combination, either it is series or parallel, or it is in the combination of RLC. Okay, either series or parallel. So that is at least one source and one element if it is a resistor. If it is general case, if it is a combination, you can use for the depending upon the application. If it is required for the first order, at the time you have to go for either RC or RL. If it is required for the second order, at that time you have to go for minimum either three elements, that is a RLC components. Otherwise, at least you have to take for the L and C. Okay, so these are very important elements in this electrical engineering. Now we'll see the differences between these based on the different parameters. Okay. Now we'll see that first one. So this is the chart, comparison chart between the active components and passive components based on the different parameters. First we will take the nature of the sources. So first, active components deliver power or energy to the circuit. Passive elements or components utilizes the power or energy in the circuit. Okay, so active it delivers and passive it utilizes or uses. Examples, so that is voltage, current, diodes, transistors, SCR, integrated circuits, etc. These are the active elements. In electrical, generally we are using VI, right? In circuits, particularly electrical circuits. So, in electronic and power electronic applications and all, so we are using device. Those are diodes, transistors, SCR, silicon control rectifier, integrated circuits, etc. These are using for the active elements in electronic applications. Okay. Okay. In the case of passive elements, resistor, capacitor, and inductor, these are the mainly used for the electrical circuits. These three are passive elements. The function of the components in the case of active, that is these are the device which produce energy in the form of voltage or current. But passive components, those are the device which stores energy in the form of voltage or current. If it is a capacitor or inductor, these two elements are storing the energy. So stores in the form of voltage and or current. So that is also in the magnetic field as well as electric field. Okay, if it is capacitor, it stores in the electric field. If it is an inductor, it stores in the magnetic field. So the power gain parameter. So active components are capable of providing the power gain, but so passive components are incapable of providing the power gain. Okay. Flow of current also. Active components can control the flow of current. So passive components cannot control the flow of current because these are delivering and those are using. Okay, so that's the reason they can't control passive components. Passive components cannot control the flow of current. Requirement of external source. So active components require external source for the operations, but passive components do not require any external source for the operations. Nature of energy. So these are like donors. They are giving and supplying, right? So energy donors. And the passive components, those are the acceptors, only receiving part, right? Those are the energy acceptors. Okay, so these are the comparisons between active components and passive components. Okay, next another classification of elements. Okay, based on the directions of current, we can say here unilateral elements and bilateral elements. The unilateral circuit element does not offer same resistance to the circuit of either direction. Okay, so that means if it is forward direction, it gives some current. If it is a negative direction, it is giving another current. It is not in the same current. Okay, that is the resistance of unilateral circuit element is different for forward current than that of reverse current. This figure you can see here. So both are the diodes. One way it is a forward bias, another one it is a reverse bias. This is a forward bias. This is in this direction. So another one it is in the reverse direction. If it is this. Okay, reverse direction, right? But both are not having same. It is R1 resistance value and this is R2 value. R1 is not equal to R2. Okay, so examples of these elements are diodes, transistors, etc. Okay, so this diode as a unilateral circuit element, when it is in the forward direction, in this direction, it offers only very small resistance, okay, and conducts. When it is in the reverse direction, that is a reversal bias, at that time it offers very high value of resistance, okay, and does not conduct, it won't allow the conduction. So this is the unilateral element. In the bilateral element, generally those are the, you can say, resistor, capacitor, inductor. These are the bilateral elements. Now we'll see that. Bilateral elements, conduction of current in both the directions in circuit element with the same magnitude is termed as bilateral circuit element. Bi means direction, right? Sorry, not that is a double. Bi means a double. So here bilateral means current, it flows in both the directions. That is the meaning. But only thing here you have to see either it is in the forward direction or reverse direction. Current magnitude should be same magnitude. Then only it is coupled by directional element. If it is having both different values, at that time it is not, right? So the conduction of current in both the directions in a circuit element with same magnitude is termed as bilateral circuit element. It offers some resistance to current flow in both the directions. You can take all the passive elements here, resistors, capacitors, inductors, etc. These are the bilateral elements. Okay. This figure shows the bilateral circuit elements can conduct from both sides and offer same resistance for current from both the sides, either side. Okay, you can see here this one it is one way. So this is the in this direction also same current, that is a I, and this one also. Whatever the resistance here it is, this is equivalent to this one. R1 is equal to R2, right? So that is this R1 equal to total value. So that means current resistance values are same in the both the direction. Similarly, you can take inductors, capacitors also. Okay. Now we'll see the another classification of elements. So those are the linear and non-linear elements. Already we know, even we have studied in the previous subjects also linear element, non-linear, linearity, non-linearity principles. Same only here, but here we are taking elements. Which element follows the non-linear property? Which one follows the non-linear? Circuit, sorry, a system, or you can say element is said to be linear if it obeys the principles of additive and homogeneity properties. If it follows the or obeys the principles of these two, additive and homogeneity, then the element or system, it is called linear system. For linear elements, the current is always proportional to the voltage. Already we know Ohm's law based on that. So current I is directly proportional to V. I equal to V by R, right? That is the connection. So the VI characteristic of linear element is straight line passing through origin at all times. So those are ohmic resistance, conductors, etc. So if you are taking this one VI relationship, okay, so this one it is I, this is I, and this is the voltage, okay, so it should be passing through origin. That is the main. If you are taking this one, it should passing through origin. For, that is also at all times. So then it obeys the both the properties homogeneity and additivity. So the type of elements are called linear elements. Okay. Now, what is homogeneity? Homogeneity property is nothing but when I1 is the current, circuit current for the applied voltage E1. If we assume here E1, it is the applied voltage E1 and current is I1. Applied voltage KE1, the circuit current should be KI1, where K is a constant. Okay, so that is, if you are applying, that is a E1 multiplied by K. So current also it is multiplied by same value. It is homogeneity principle. So another one that is also here in this figure also you can see how much it is. Same thing only. If it is top, it is M fixed value. It is multiplied with that. And second one it is additive property. Additive property is okay. Additive property. If I1 is current for applied voltage E1, I2 is the current for voltage applied voltage E2, then the total applied voltage E1 plus E2, the current should be I1 plus I2. Okay, that is at a time here what is happening. So at a time you are taking single source E1 voltage. So at that time current is I1. In the second case, so E2 is the current. So at that time current is I2. When you are taking both the sources at a time, that is a total you are applying here E1 plus E2. At that time the current should be I1 plus I2. Okay. So all the elements which are following these two principles, then those elements are called linear elements. Okay. All the elements which are not linear and do not obey the principles of linearity, that is additive property and homogeneity property, then those elements are called nonlinear elements. A nonlinear element does not obey the Ohm's law. Okay. Examples: diode and other semiconductor materials. Even resistors also, if it is a non-linear resistor, it won't follow the Ohm's law. If it is a linear resistor, it must. That is, it should follow the Ohm's law. It is following because it is already it is a relation between V and I. I is directly proportional to V. Okay. So this is the difference between linear and non-linear elements. Next, another classification we'll see here, that is, these are the few figures. So, time variant and invariant systems. By name itself, we can understand what you mean by that. Time variant and time invariant or invariant system. Vary changes, invary fixed, right? So, an element is said to be time variant whose VA characteristics changes with respect to time with the time. An element is said to be time invariant whose VA characteristics do not change with time. Right? So here you can see if okay if time varies, you can see T1, T2 at that time. These are time varying system. If it is time fixed value at that time, this value it is a fixed only, right? For example, if you are taking, if it is not depending on time, for example, this is time t, and this is the, if you are taking, for example, so v of t, whatever it is fixed value. I am taking here only 4. Some value it is 4. It is not depending upon time. It is not depending on the time. I am taking the just relation between these two. Whatever you are taking, vi, right? If it is fixed value, what you will get? It is a constant only. You are taking 4i. Whatever the value you are taking, that is a fixed value. It is a fixed value. So it won't change with respect to time here. If it is this. So for example, if you are not taking just whatever the value, x, for example, x equal to 1, y equal to 2x, whatever it is, 2x. Here what is there? This one it is fixed, this is a also same value only, it won't change with respect to that. So for example, if it is with respect to this, y equal to 2t. So if t varies, it is increase. If suppose if it is t equal to 1, y equal to 2, right? So another case, if t equal to 2, for example, y equal to 4, varying, right? So output is varying here. So if you are taking this relationship P and I also, depending upon the time, if time varies, these two relations will be varies, characteristics will be vary. If not, so if it is varies, that system it is, that element it is called time variant element. If it is not depending upon the time, so then those are well called time invariant elements. Okay, so that is time invariant element. Next one, another classification it is, that is lumped element and distribution element. You can say here lumped network circuit or lumped circuit distribution circuit. A network in which all the network elements are physically separable is known as lumped network. Most of the electrical networks are lumped in nature. Okay, how it is we'll see. When the voltage across and current through the element do not vary with the dimensions of element, then those elements are called lumped circuit elements. Example, resistors, capacitors, etc. I can say those are the elements. Okay, for example, if you are taking resistor, so it won't change with the dimensions of the element. Whatever the voltage across the resistor or current through the resistor, it won't vary with the dimensions. Those elements are called lumped circuit elements. Okay. Now, in the case of a distribution network, generally transmission line, we can take this example for the distribution network. So, a network in which circuit elements like a resistor, resistance, inductance, capacitance, etc. cannot be physically separable. In the lumped network part, you can take separate one. Resistance is this, capacitance is this, inductance is this, like that. But in the case of distribution network, you can't physically separable for the analysis purpose. It is always combining with one or two, that is R and C or LC or L, like that. Okay, so the best example of such network is transmission line, where resistance, inductance and capacitance of transmission line are distributed all along its length, cannot be shown as a separate elements anywhere in the circuits. Okay, so these are the distributed networks. So those elements are called distributed elements. Okay, now till now we have discussed about circuit elements based on the different parameters. Those are active and passive elements. Okay, time invariant and variant elements, linear element, nonlinear elements, lumped elements, and distribution elements. So, unilateral and bilateral elements. Okay, thank you for listening.